Our next speaker is Jeff Vetsch. He manages soil science research at the University of Minnesota at the Waseca Southern Research and Outreach Center. He conducts applied research in the areas of nutrient management, water quality, and cropping systems, primarily under corn and soybeans. Jeff has done considerable amount of work through AFREC, and he's highly respected by that council. So thanks for being here today. He's driving down to Texas afterwards, so he's going to talk really fast.
Hey, if you know me, I talk really fast anyway, so it'll be probably even faster. Thanks, Bruce. So I'm going to talk about our band applications better than broadcast. This is a project we've been doing with AFREC at a couple locations for the last 3 or 4 years. So why might we want a deep band P and K fertilizer? Well, I think first of all, we think of kind of when got low soil tests, maybe band is going to be more efficient, and our past research would probably suggest that that's the case. If you're in a strip till system or your no-till system, it's pretty obvious that the band might be better than a broadcast. And also in strip till, it makes a lot of sense because it saves time. You can do both operations, fertilization and tillage at the same time. And also it's important to reduce the phosphorus left on the soil surface because that reduces phosphorus runoff. And if you think about all the water quality issues they've had in the eastern U.S. and in the Ohio Valley around the Great Lakes, a lot of that was they went no-till and they kept putting all their phosphorus on the soil, on the fertilizer or on the surface, and they didn't incorporate it, and they results in phosphorus in surface waters from phosphorus runoff from dissolved reactive phosphorus. So keeping it in the soil is a good place to be in those no-till systems and reduced till systems. It also minimizes the stratification of these immobile nutrients from broadcast applications in the same reduced till system. So not only is that important from a water quality standpoint for phosphorus, but in potassium, we have a plant that takes up, as our morning session talked about potassium, we take up a lot of potassium and it just stores it in the residue, especially in corn. As soon as the grain's removed, we don't remove a tremendous amount of potassium in the corn grain. We actually take off more in soybean grain, but the rest of it just stays in the residue, recycles back to the soil. So in a no-till system, if you're broadcasting potassium, you're leaving it all on the soil surface because the plant is pumping it out of the soil and leaving it on the soil surface, and you're broadcasting it on the soil surface. So you end up with it very stratified in the surface soil, and that's not necessarily a good thing. Fixation or tie-up of P and K for phosphorus. This is in very high or very low pH soils. With potassium, we talked about that all this morning, about how complicated it is between the illites, the vermiculites, and the smectites. And we know that those smectite clays that we have in our Des Moines lobe till in south central Minnesota are the ones that have that potential to tie up K in those inner layers, especially when it gets dry, the soils get dry, or when you dry the samples. Greater yields and fertilizer use efficiency with band K applications versus broadcast. George Ream and John Lamb in 2004 showed that banded K increased corn yield in ridge till system, but it interacted with certain hybrids or genetics. Antonio Malorino's group in '99 and 2004 found an occasional corn yield response to banded K, but it wasn't very consistent. And they found no effective placement on phosphorus. And then the economics, can we use less fertilizer? And that's the question I get the most is, can I use less fertilizer if I band? Because that'll increase my return on investment to fertilizer. And this is a good option possibly on some rented land or when we have high fertilizer prices like we do today. So at the U of M, our current research or current University of Minnesota fertilizer guidelines suggest significant rate reductions when using band compared to broadcast applications. Here at the top of this chart, we got soil test levels very low, low and medium for phosphorus. We got Bray phosphorus, Olson, and at these very low and low categories, our band application recommendations are about half or 50% of what our broadcast is. And then when we get to the medium category, that amount gets a little smaller, and then we get to the highs and very highs, it goes away. And the same is true for potassium down here at the bottom. The range is for very low, 0 to 50, low 51 to 100. Again, we have about a 50% reduction in rate if we ban versus broadcast. What about our neighboring states? What do they recommend? In South Dakota, their recommendation fertilizer guidelines were reviewed by Clark and originally written by Gerwing and Gelderman in 2005. And this is kind of their comment when it comes to reducing rates. banding P and K near the seed as a starter frequently results in more efficient use of these fertilizers. Therefore, when starter phosphorus and potassium are used, rates can sometimes be reduced by 1/3. Now ours go up to a half, these are 1/3 or more, and still reach maximum yield. However, when rates are reduced, application may be below maintenance levels, resulting in soil test level decline with time, especially with phosphorus. So recognizing that if we're going to reduce these rates, we're probably going to see a decline in soil test values from the higher levels, or if we're at lower or medium levels, it's probably going to stay there. It's not going to build. That's the key point. And over here on the right, this is data from studies in 98 and 99 in South Dakota, where they looked at the difference between broadcast and band. So this one here, when we're less than 1 or less than, the yields are lower than a 1-to-1 ratio, showed that the band applications were better than broadcast. In fact, broadcast was only produced about 95% of the maximum yield that band did at very low soil test phosphorus, 4 to 6 part per million. I assume that's Olson. Or at 68, it was about 98% or 99. And then once you got above 10 part per million, there was no advantage. And that's kind of based on our recommendation system as well, at these low soil test levels. So what about North Dakota? I know Dave already left, but in the 2018 revision of their recommendations, he wrote, the rate of phosphorus and potassium recommended in these tables is the amount to be applied as a broadcast application. Because banded fertilizer generally is used more efficiently in the year of application, again underlined, the amount of P2O5 and K2O in the tables can be reduced by 1/3 when banding, and the result will be similar to the yield with the full broadcast fertilizer rate. So they also say we can reduce up to 1/3 and get the same yield. But again, he makes the comment, like South Dakota, broadcast recommendations of P and K for low and very low testing soils may include buildup P and K rates. So when rates are reduced, the soil test levels are not going to be increased over time. So if you're at these low levels and you're not putting on those broadcast rates, you're not going to build soil test levels up to higher levels. So our studies, we wanted to look at, can we still justify, and are these rate reductions still valid? And then also, let's take a look at a band that's probably more traditional. What we're going to see today is a band that's below the row, because we just don't have a lot of starter fertilizer being applied at those kind of rates with planters anymore. So we had 2 research sites, locations for this study, and the soil types and the parent materials were different. We had Waseca, which is a Nicollet-Webster clay loam soil, a glacial till. So it's got more smectite clays, or the higher smectite ratio, as Dan said, probably greater than 3 or 2.8. And then we have, and that's a poorly drained soil. And then we have the Rochester Mount Carroll silt loam, which is a well-drained loess that has more illite or less smectite. So the ratio is probably less than 2.5 to 1. Both of these sites had both a phosphorus and a potassium study. They were adjacent to one another. The previous fertilizer treatments that we had in these studies created replicated plots with a range in soil test values at each of these locations from previous studies that we had done there. So at Rochester, our Bray P range from 4 to 24 part per million among treatments, and our K range from 75 to 241, but in separate studies, of course. The Waseca was 2 to 26 Bray and 73 to 208. And these were the soil test levels in 2019. So we have a wide range from low to very high soil test levels across this replicated experiment. So then we took those 20-foot wide plots and we split them, and we banded on half and we broadcast on the other half. So we made 2 10-foot plots out of them. And the band was applied in the crop row about 5 to 6 inches from below the soil depth, but not 5 to 6 inches below where the seed was, just below the soil depth. And the broadcast applications are just obviously broadcast incorporated. So it's important to recognize that the band of broadcast fertilizer was applied in the fall at Waseca, and the band was applied after fall full width tillage or conventional, conservation tillage. So the band should not be disturbed with pre-plant tillage, which was just shallow 4-inch field cultivation. And we put all the treatments on at Rochester in the spring, which is fairly conducive to doing that on those loess soils. Not so much in the glacial till soils. Precipitation and weather did have impact of these studies. I would say 2020 was a dry spring, April in particular at both sites, but that's not always a bad thing for agriculture. A dry spring usually means early planting. And then the weather after that was almost ideal at both locations. Very timely rain, more than above normal precip, excellent yields. However, in 21 and 22, drought affected both sites in both years, and especially at Waseca. If you look at the 2021 Waseca precip by month, see April was a dry year, May was below normal, 30-year normals are right here. June was below normal, July was below normal, and then we got a good rain in the end of August. It kind of saved the crop, or we might have had a crop failure. And then September was dry, but we only had 14.13 inches of precip of our normal, which was only 60% of normal at Waseca in 21. In Rochester, the spring was dry, May had normal, June was dry, and then we kind of alternated, and the rest of the growing season was pretty good. We were not too many, we're only about 1.5 inches below the normal, and we had very good yields in 21 at Rochester, even though it was a dry spring. In 2022, you look at the results of precip for Waseca and you'd say, oh, you had 20 inches of rain. That was a good year. But it came very erratically and in large amounts. Each month of May, June, and July had one event that significantly contributed to the total monthly rain. In June, 80% of the rain came in 6 hours. That's usually not a good thing to happen in June. So even though we had our total precip was near normal, it was not well distributed, and it led to precipitation deficits and drought stress for the crop. And Rochester was actually a wet year in 22. So this is a first picture from June of 2020. Over here on the left, we have 60 pounds of K2O broadcast right here. And here we have it on the right as a band. And this is at a soil test, ammonium acetate dry test of 90 part per million, which would be considered low by our current standards. And you can see this corn is shorter, and you can see the yellowing along the leaf edges, the potassium deficiency. And this was the same rate, 60 pounds of K2O, and this corn is significantly taller, has a lot more leaf area index, and very little visual symptoms of deficiency. This is an even more extreme one here. This soil test was only 85. The band treatments, or the broadcast, is over here on the left. You can see how stubby and small these plants are and how much deficient they are versus the band on the right, which is much better, much taller, a lot more leaf area, and also much less deficiency symptomology. So we're going to show some of the same tables now, and they're kind of be the same thing in each one, but we'll go year by year because each year was a little different. So we're going to compare the band versus broadcast over a wide range of treatments. So the band rates were either 45 or 60 pounds of K2O in the first year. And when we look at banded versus broadcast at Waseca, there was virtually no difference in soil tests from the previous year because the study had initiated where they were the same on both sides. We wanted to show that it was equal. Ear leaf K was numerically greater with band than it was with broadcast, but it wasn't statistically different, as was grain yield. We had numeric about 4 bushels greater, but it was not statistically different. We also had these treatments, 60 pounds of K2O annual broadcast and 120. These were kind of our standards. If we apply more than enough, are we going to see, are these band treatments going to be deficient or not as good as those? So when we look at the 60 pounds, this was applied annually in the same spot for up to 7 years. 60 pounds, we had a soil test of 121 versus these, which was much lower. But our ear leaf K was about the same as these. And our yields were actually the same or even slightly lower. But where we applied 120 pounds of K annually as K2O, we had a soil test of 151. Our ear leaf K was much higher and our yields were higher. So that was one year where we saw that the higher broadcast rate yielded better than the band or broadcast. We look at the Rochester data, the banded treatments and the broadcast treatments had similar soil tests. The band had numerically greater ear leaf K, but it wasn't statistically greater, but it did have a 6 bushel yield advantage over the broadcast in 2020. The other thing to note is, as Dan and Fabian, or Dan and Dave and Antonio talked about, just the differences in soils and the mineralogy and how that affects the amount of K that the plant sees. Here we're at a soil test of 100 in Waseca and our ear leaf K is 1 or less. How many of you know what the critical value at R1 for ear leaf K is? What's the minimum? The minimum is 1.75. So we're way below this minimum, way below it. But here at Rochester, where our soil test values are virtually the same, our ear leaf K is considerably greater. So there's definitely a soil difference going on here with the illite clays in the Rochester silt loam versus the smectite clays in Waseca. Then when we look at the 60-pound treatment, it had higher soil test levels and higher ear leaf K, but yields were similar. When we go to the 260 pound or the 120 pounds K2O annually, we had much higher soil test K and higher ear leaf K and above the critical value, but yields were about the same. We really did not increase yields. So this band treatment was very efficient at that site. Even though the ear leaf K was marginal and the soil test was very low, it yielded as well as that high treatment in Rochester in 2020. So what about phosphorus? Again, we're looking at averaging over 30 and 45 pounds of P2O5 per acre, and it was applied as TSP or triple superphosphate. The soil test levels initially were about the same. After the first year of application, they changed just minorly, so we're doing a good job of measuring our soil tests. Ear leaf phosphorus at Waseca was not different and yields were not different. At Rochester, the soil tests were similar. At Rochester, our Brave P, when we banded, got a little bit higher than the broadcast, suggesting that maybe we're sampling that band a little too much and it affects our soil tests. And that's a theme that you'll see happens occasionally. Interestingly enough, our broadcast treatment at Rochester for phosphorus had greater ear leaf phosphorus concentration than our band, but yields were the same. And again, look at the concentration of phosphorus in the ear leaf at Rochester versus at Waseca. It's considerably greater, even though soil test levels are similar. So again, it goes to that soil effect. So year one observations, we had growth differences that were observed at Waseca for P and K and for Rochester for potassium. And generally the band had taller, bigger plants than the broadcast at both locations. We observed K deficiency symptoms. Most were in the broadcast treatments. The banded treatments actually look quite healthy, even though they got the same rate. Small yield response to banded K at Rochester, no yield response to P placement at either site. And I think over here, this thing is really important. When you think about these plant tissue tests, you just can't overreact and get too excited about these low and marginal K soil tissue tests, because we did not see big yield differences. Even though the K tissue tests were way below these critical values with some of these band and broadcast treatments at these really low rates. So let's move on to 2021. Over here on the left is the broadcast 60 pounds, and this is at a soil test of 84, and this was at Waseca on early July. Over here on the right is the band, and you can see that there's less K deficiency in here. You can see it all the way down in between this row. Every one of those leaves, lower leaves, has very, very K deficient, those burnt or burned edges. So a huge visual difference between those two locations, or between those two side-by-side plots because of placement. When we look at the table, now our rates, we've added a whole bunch of extra treatments that got applied this year. So now we have K2O rates that range from 30 to 60, but we still looked at the average over all of them, band versus broadcast. Our soil test K in June of 21 was 94 or 95, so it's virtually the same. Our banded K treatments had greater ear leaf K theirs versus the broadcast, and that's what we saw visually, but the yields were the same. When we look at the 60 pounds and the 120 pound annual treatments, with the 60, the soil test was just slightly greater, but the ear leaf K was greater, but the yields were not. And with the 120 pound treatment, the soil test K was only 138. That's pretty low. If you remember last time, it was greater than that. This was a dry spring and that dry growing season. And it's like our soil samples for K that year just dropped tremendously at Waseca. And Dan, I know we've talked about this before, that sometimes you'll get this year where soil test K, it just is lower. And then the next year, if it's wet, it'll jump back up again. Our ear leaf K was greater with the 120 treatment, but the yields were the same. So no yield advantage, and actually pretty good yields considering we had 14.3 inches of growing season precip. And it still got over 200 bushels. Our Rochester site, the band versus broadcast, 90, 91, virtually the same soil test levels. Look at the difference in ear leaf K again. No differences between band and broadcast, but 146, 148 versus up here at Waseca, where it's much lower. Yields better than Waseca and better with broadcast at this year at this site in Rochester. The 60-pound treatment annually had very similar to the band or broadcast at all those rates, and yields were similar. And the 120 had a higher soil test K, a higher ear leaf K, and yields were trending upward, but not statistically greater. So the other thing you want to think about is that I think here at Waseca, the yields and the drought definitely capped yields, but we still got 200 bushels, and we still did it with these really low rates, either band or broadcast. About phosphorus, it's kind of the same story. We see some differences in soil test when we band versus broadcast, but at Waseca, no differences in ear leaf phosphorus, no differences in yield. Similar story at Rochester, no difference in soil test, no difference in ear leaf P, and no differences in yield. So it just doesn't seem to make much difference for phosphorus, but it does occasionally for potassium. And again, look at the ear leaf P at Rochester versus Waseca, considerably greater. So observations from year 2, 2021, growth differences were observed at Waseca for K, and band was always better than broadcast. We also observed K deficiency symptoms, and almost all of them were in the broadcast treatments and looked much better in the banded treatments. Even though the Waseca site didn't yield more with band, the plants looked healthier all year long. The small yield response at Rochester, broadcast was actually better than band, opposite of the previous year. Was that a result of our spring application of K in this below the row in this dry year? I don't think so at these really low rates. These are not high rates. That's not a lot of salt to put below that row, even in the spring. No yield response to phosphorus placement at either site, same as the previous year. The economics, we're kind of getting these contradicting yield responses, so we need to do this one more time. So we looked at it in 2022. Here's some pictures at Waseca. This is a 30 pounds of K2O treatment with a soil test of 103. We had a fairly dry growing season with these intermittent heavy rains. It was not hard to find severely K deficient plants in this study. This is the healthy 120 pound annually treatment with the soil test K of 191. Now remember 191, go back here a couple of charts. Last year it was only, oh, that's too far back. Last year was only 138. Now it's up to 190. So it's changed dramatically in 1 year, and it could be driven by moisture when we sampled. So the rates that we comparing are 30 to 60. So here's our soil tests for the band versus broadcast comparisons. They're very similar. We have a slightly greater ear leaf K and no yield difference. Now I don't have stats yet. I was trying to get that done last week and I ended up being home sick a couple days and just didn't get it completed, but I will be working on that in the next couple weeks. When we look at our 60 broadcast at Waseca, soil test was similar, ear leaf K was similar, yields were similar. When we look at our 120 broadcast annually, soil test K was much greater, 190, ear leaf K was greater, 1.43, and our yields are trending upward. Now at Waseca, we had some issues there this year. We had drought sporadically, we had corn rootworm feeding on transgenic hybrids, and we had some high thunderstorm winds that laid some of this corn down in July. So this was a pretty tough environment, and we still yielded 181 to 188 with all those challenges, but it may have taken some of the separation among treatments away because of all these other issues or concerns. At Rochester, our soil test values are 112, 114, so they're actually a little less than at Waseca. But look at our ear leaf K at Rochester, 1.58, 1.55 versus 0.9 and 0.94. So again, this soil differences are huge in these two soils. Our yields were greater with the band, again at Rochester in 2022, 7 bushels. Our 60-pound annual treatment had similar soil test levels, similar ear leaf K, and similar yields. Our 120-pound treatment had much higher soil test levels, much higher ear leaf K, but did not increase yield. So again, at Rochester in this year, we got by with these really low rates in a band and produced the same yield as much higher rates and much higher soil test levels as a broadcast. But what was interesting is this is the first time we saw this interaction between rate and soil test method or soil test level. All the other years we expected to see this, but we never saw it. But in 2022, we finally saw this at Rochester. So this is an interaction between the potassium fertilizer rate, its placement, and then what the soil test level is. So over here on the y-axis, we got corn grain yield. I graphed this as box plots so you can kind of see the variability in some of this data. These first two box plots are the annual treatments. This is the 60 pounds annually, which was 115 part per million soil test. This is the 120, which was 208. This is a 30-pound band and 30-pound broadcast comparison at a soil test around 120 part per million. And you can clearly see that the band treatment is much superior at these low rates of application with a medium or low soil test level. The same is true over here in the next comparison. It's 45 pounds in a band in this bar versus 45 broadcast in this one. And the soil test level's around 110 here, so a little bit lower. And that's why we're increasing the rate. And then the last pair is a 60-pound rate comparison here in the band and there in the broadcast. And this is the lowest soil test levels down around 100 part per million ammonium acetate K. And we don't see much of a difference when we get to those 60 pounds rate, but we see a huge difference at these really low rates. So this is the first time we saw this interaction between rate of application and response, not to crop yield, but also to the difference between band and broadcast. And what it's saying is that these bands are really effective even at extraordinarily low rates with these low to medium soil test levels. This suggests there's a high fertilizer use efficiency with this band application, as we saw in this site year. The 30 and 45 pound treatments had greater soil test K than the 60, and thus that's why the rates that we applied were different. As the soil test level goes up, we go down with the rate and vice versa. But still, these rates are much lower than our broadcast and build and maintain recommendations. If we were going to put on a broadcast with soil test levels this low, we would recommend 120 to 140 pounds of K2O, not 60. So what about phosphorus in 2022? At Waseca, the banded treatments had a little bit higher soil test. Ear leaf K yield not different. At Rochester, similar story, no difference in ear leaf K. Maybe a 5 bushel increase in numerically in yields. Whether this is significant or not, I'll find out when I get the analyses done. So, but in general, we did not see much response in phosphorus. So is there an effective P2O5 rate on soil test P and yield at Waseca? So I wanted to look at this and show you this because we had treatments where we put no fertilizer on for 3 or 4 years just to see what would happen, how fast the soil test would decline, and if they were going to get a big yield decline. So this is P2O5 rate 0, and for how many years? 4 years in a row. And this little superscript 13, 16, and 14 relates to the treatment number and what the soil test was that's written down here when we started the study in 2019. So this first treatment was 0 for 4 years. And it was 17 part per million when we started. And it really isn't band or broadcast because it got 0, but I got to put it somewhere. So I put it under broadcast. So the soil test in 2021 was 10.3 part per million. The yield in 2022 was 184 bushels. 0 for 4 years and started at 18. The soil test was 15 and the yield was 190. 0 for 3 years, and then we put 100 pounds on for the 2022 growing season because we wanted to build the soil test back up, and 192. So only an 8 bushel range from a site that had a 10 part per million soil test with no fertilizer phosphorus for 4 years to a site that had a higher soil test and we had just put on 100 pounds broadcast in that year. Now, these are the rates that we put on: 30 for 2 years, 30 for 3 years, 45 for 3 years, and really not much difference. Soil tests are the same across these treatments. There's a little bit of advantage. It seems like the soil tests are a little higher when we sample after a ban versus a broadcast, but yields are all the same. Phosphorus application just does not affect this much when it comes to Waseca site, either how much we applied it, but it was surprising to see this very small response, only 8 bushels in this year, where we had some water and some other issues maybe limiting yield. What about at Rochester? So at Rochester, the zero treatment for 4 years had a soil test of 7.3. It was 206. The zero treatment for 4 years had a soil test of 8.0. It was 207. The zero treatment that then we put 100 pounds on went up to, or was 11.5. It was 210. So only a 4 bushel difference among those. So it says that this Rochester soil can get by with really low soil tests and really have very marginal yield penalty. I know this is hard to believe because people tend to think that, if I don't put P and K on for a couple of years, my soil test is going to drop off the table and my yields are going to just plummet. And they don't. In a lot of these soils, you still can produce 93, 96, 97% of maximum yield, even if you don't fertilize for a couple of years, even with medium soil test levels. And in this Rochester site, these are low soil test levels. They're less than 10 Bray. The 30 for 2 years, 30 for 3 years, 45 for 3 years, really not much difference. There is a range from 202 to 213, but it's probably just random variation because we didn't see much going on up here. So observations from the year 3, we didn't see any growth visual differences in year 3. We found potassium deficiency at Waseca, but there were no differences between the band and broadcast. And that was common in past years at both sites, but especially at Waseca. Western corn rootworms, thunderstorm winds, and lodging kind of kicked this field's butt in Waseca, but it still yielded 185, which I found hard to believe when I saw what it looked like in early August. I thought it was going to be a complete train wreck. For potassium, Waseca no yield response to K rate or placement. The annual 120-pound K2O treatment had numerically greater yields. Rochester, the band was greater than the broadcast. That was the 2 out of 3 years the band was better than the broadcast. But at Rochester, it was only with the really low rates. When we got to 60 pounds, then it was equal. For phosphorus, no yield response to placement 3 years in a row at Waseca. Broadcast yield was numerically a little better than band at Rochester. Don't know if that's significant. It was only in one set of comparisons, so I'm not too excited about it. I think it's pretty fair to say that it doesn't make much difference where you put phosphorus. So the 3-year summary, I got a couple more slides. How am I doing for time? Okay. So for potassium, Waseca, no significant yield response to K placement in any year, but the band was numerically greater than broadcast in 2020. It was 4 bushels. The other year, it was a couple bushels, but it was always better, but it's not a lot. You're not going to get rich, banding K, at least at this Waseca site. At Rochester, the band was better than the broadcast 2 or 3 years, but it was opposite 1 year. Averaged across the sites, the annual 120-pound treatment increased corn yield at 2 of the 6 site years. That's not a big number, considering how much more at today's potash prices that would cost. But do recognize that the soil test levels were much higher, the earleaf K was much higher, the plants looked healthier. But we're putting on 2 to 3 times as much. But that was our maximum, this is our high end. If we put on more than enough, what can we do? For phosphorus on these neutral to weakly acid soils, generally, I just could not find any fertilizer placement had no effect on corn yield. Reducing P and K fertilizer rates. Often reduced rates produced equal yields compared with greater rates or treatments with high or very high soil test levels. So can we reduce rates? Should we leave that in our recommendations? Ultimately, it's Dan's decision and he's part of this study. But there's data in this database that says, yes, these reduced rates can work. You don't need to build and maintain to above critical value levels. You can apply at these really low rates, and maybe band is more effective for K, but it doesn't matter, band or broadcast for phosphorus. But when we do put P or K rates, or when we do lower these P and K rates, the soil test levels are either going to decline from high levels to medium, or they're going to stay at low or medium levels if they're already at low or medium levels. And I got NDSU, SDSU down here to remind me, because that's the text that I read you earlier that was in their guidelines. And that's important. You have to be comfortable with these low to medium tests if you're going to apply these really low rates, because it's not going to go up. And if it's up high, it's going to come down, and you can't panic. So what's my recommendation? Does placement of P and K matter? Not for P on these acid soils. On highly calcareous, high pH soils, the older data says yes, it does. And I think that that data is still valid. And there's still some of that data that's being collected in other states as well. But for phosphorus, it's probably more of a starter, get it even closer to the seed than in a deep band. But for K, obviously pH isn't going to matter. Data suggests banding K below the row is better than broadcast. It's not a lot of data. It's not a very convincing argument, but it suggests that it is a little bit better. But should I go out and buy a banding tillage implement? I wouldn't, only if you're planning to switch to strip till. And if you're currently doing strip till and you're always wondering, should I be broadcasting versus banding? I'd keep banding, because I think you can get by with reduced rates. You can keep those soil test levels in the medium category. And there's data in here that supports doing that and still getting very good yields. Now, can I make more money banding reduced rates of P and K? And that's got the extension answer of it depends. At current fertilizer prices, probably. But the economics are driven by applying reduced rates, not yield enhancement. So you go back to the very first talk this morning, Mike Schmidt talked about the 3 scenarios to getting economics for the AFREC program. One was getting higher yields and putting on more fertilizer. One was putting on less fertilizer and keeping the same yield. That's where this is going to work. You're not probably going to see a big yield response. These responses were 4, 5, 6 bushels, and sometimes it wasn't significant. So you're not going to get a bunch more yield, but you might be able to reduce fertilizer rates. And that's what's going to drive your economics if you're going to have an economic advantage. And we still don't know the effects of these really low rates on soybeans in a rotation. And the Soybean Association's funded us. We're going to do a residual study this next year at both of these sites to look at soybeans and these really low rates, and is it costing us soybean yield versus broadcasting and keeping the soil tests at higher levels. And then I think the last point I'll just make is, are you or your fertilizer retailer comfortable with low to medium soil test levels? Because I've seen this trend over my 30-year career that our soil tests are just off the charts, especially for phosphorus. And I hear it from our local retailers, oh, those 20 part per million, that's way too low. You need to be 30 to 40. And I see fields that come in all the time. Farmers will bring in their prescription maps that they're going to apply, and their soil test phosphorus for AP will be 30, 35, and they're still putting on crop removal. When MAP or DAP is $800, $900 a ton, you don't want to do that. Take some out of the bank, mine some out of the soil, especially on these soils. I mean, you can get that soil test down to the medium category and have a very small yield penalty. I showed it in the data, just the last 2 or 3 tables I showed. So with that, I'll wrap it up and acknowledge the funding from AFREC. And I got to get that new modern logo. I got the old logo. And also recognize Dan Kaiser, who's a co-PI or co-collaborator on this project, and Kyle Holling, my researcher, who helps me with all the field work. My contact information's over there. Do you have time for questions? Oh, we got lots of questions. How deep do you recommend banding P and K in a strip till system? And do you recommend the different depth for coarse versus heavy soils? Yeah, that's a great question. So I think most knife tillage strip till implements are run between 7 and 8 inches typically, sometimes a little shallower, 6 inches, but most of them go 7, 8 inches deep. And when you dig in the furrow, you'll find all that P and K, gravity works. It goes to the bottom of where that trench is. Is that too deep? Maybe a little too deep for phosphorus, but not too deep for potassium. I wouldn't worry about the K being down there at 7, 8 inches. But if you want to get that starter fertilizer response with phosphorus, you're probably still going to have to put on starter. That K or that phosphorus down in the bottom of that 7, 8 inches is not going to give you that starter effect. So how deep should you band? I think you want to get it at least 3 inches below the seed. So that's probably the minimum, but recognize that there's two different things going on. It's the ammonium in MAP and DAP that causes seedling injury. So if you can put on triple superphosphate, which is now available again, it wasn't for like 15 years, but it's around. You can put on as much as you want, and you can put it right around the seed, and it's not going to hurt the seedlings. In coarse textured soils, but then of course the potassium's got a higher salt content. But if you're strip tilling in the fall, I wouldn't worry about it. The depth doesn't have to be that far below the plant. Now, obviously, the retailers and the manufacturers of strip till equipment will tell you, well, it depends upon how much fertilizer you're going to put on. Yes, it does. If you're putting on 300 or 400 pounds of product, both potassium and MAP or DAP combined, then maybe it needs to be separated by 3 or 4 inches from where the seed's going to be. But if you're putting on the kind of rates I was putting on, it could be within 2 or 3 inches, and it's probably not going to hurt it. Coarse textured soils are definitely a different animal. It's going to need a little bit greater separation. Okay, the next one. Are your rates being stated as the amount of fertilizer? What were the actual levels of P and K tested? I'm not sure about that one. Are your rates being stated as the amount? So the rates of fertilizer that we applied, band versus broadcast, were in pounds of either P2O5 or K2O. The soil test levels, we sample every plot every year, twice a year in the case study. So we show the soil test levels and the rates of application to help you get a better idea of how these rates are affecting soil test over a period of time. Now, unfortunately, when we get this study all done, I'll chart that in graphs so you can see how it's changed over time. But right now, I'm just showing it kind of week or year by year. So it's hard to see that pattern. Did you have any tests on alkaline pH soils? No, in this study, these are both acid soils. The Lust soil at Rochester is pretty much near neutral. It gets limed regularly. And the Waseca soil is probably weakly acid. It probably ranges from a pH in the surface from 6 to maybe 6.8. We run out of time? Oh, one more. We typically band ahead of corn using average removal rates for corn and beans. Are we hurting yield on our beans by not banding ahead of beans too? No, if you're putting on crop removal rates for corn and beans, you're not hurting your beans any. I can guarantee you that. If anything, if your soil tests are very high, you probably don't need to be putting on crop removal rates either. Any other questions? All right. Thank you.